Welcome, I'm Professor G teaching you physics, and today's topic is collisions. Before we move on with the topic today, make sure to subscribe to my channel, Physics Friendly, and hit that bell icon for all the upcoming video notifications. All right, let's begin now. Okay, collisions, right? Interaction of objects where one object exerts force on another object is termed as collisions. Now, in any given collision, right? Momentum is conserved. So that means net momentum before collision is actually equal to net momentum after collision. So collisions are of two types. So first one is called as elastic collision, where momentum is conserved in elastic collision, and then the second type is actually called as inelastic collision, where momentum is also conserved. Now let's look at the difference between elastic and inelastic collision. Elastic is when I have two objects, right? When they come and collide, right, they actually separate from each other. They can move in any direction. If it's constrained in one dimension, they separate out in the same direction, right? In x direction. If the object is moving in y direction, so they come and collide and then move back in the same y direction. But in inelastic collision, when we have two objects, they come and collide, they stick together and then they move with a new velocity. You see the difference? Elastic and inelastic. Elastic is when two objects collide, they separate out. They can move in any direction. Inelastic is when two objects come and collide, they stick together, they cannot separate, they stick together, they move with a new final velocity. Okay, so let's look at inelastic collision, right? We have to draw pictures now. Let's say I have two objects. I'm going to call this as object 1 and I'm going to call this as object 2, right? And then the mass for both of these objects, almost, their masses are exactly same. So I'm going to call mass of object 1 as m1, subscript 1 means object 1, and then the mass of object 2, subscript 2 means object 2. So in here I'm taking mass 1, which is equal to mass 2. Both objects are of same masses. Right? This is a pictorial diagram for before collision. I have object 1 which is moving, let's say, with some initial velocity of object 1. So vi1 stands for initial velocity of object 1 as 2 meter per second, and or object 2 is actually at rest. So that means initial velocity for object 2 is 0 meter per second. So vi2 stands for initial velocity of object 2. My object 1, which is moving with initial velocity 2 meter per second is moving towards my object 2. Object 2 is at rest. All right, now after collision I have both the objects which are sticking together like that, and they're moving with new velocity. I'm going to call this as final velocity. V subscript F stands for final velocity. So this picture depicts before collision and this one depicts after collision. So we have to set up equations. So we know conservation of momentum means net momentum before collision, right, equals to net momentum after collision. So let's take one thing at a time now just to make it easier. So before collision, here is the picture. Object 1 moving with certain velocity, object 2 is at rest. So I'm going to come back to my equation here. I have m1, right, v1i. m1 stands for mass of object 1, and then v1i stands for initial velocity of the object 1, plus my object here is at rest, correct? So I have mass 2 v2i, okay, equals, now after collision they both stick together as we can see here, correct? So I'm going to bring in here. So I'm going to say m1 plus m2, both of these masses combined, and they are moving with final velocity vf. So this gives me the momentum of object 1 before collision plus momentum of object 2 before collision. This gives me momentum of both the objects which are sticking together. Hence we are looking at added masses or combined masses, as in this case m1 plus m2, moving with a new velocity v subscript f. This is equal to 0, right? Because velocity of second object is 0. Object is at rest. Plus we have m1, no change here, 1I, equals m1 plus m2, right? V subscript f. And then we can solve for anything here. So let's say I'm going to solve for final velocity. I'm going to divide both sides by m1 plus m2. So m1 and m2 cancels out, leaving with an equation for final velocity, which is m1 v1I over m1 plus m2. And of course it's velocity, so SI unit is going to be meter per second, and that's your inelastic collision. Now moving on with elastic collision. So second type of collision is what we call as elastic collision, where I have two objects, right, which come and collide and then separate out. So I have two objects which are moving towards each other like that, and then they collide and then they move back. And that's what we are trying to depict in the following figure, where I have object 1 of mass m1 which is moving with initial velocity v1I, and then I have object 2 moving with an initial velocity 2I. So they approach each other, as in this case when we have that arrow there, and then after collision they collide and then move back in the opposite direction, hence the arrows here. So before collision we have m1 v1I, right, mass times velocity. So this is my plus because it's moving in positive x direction, and then object 2 which is moving in negative x direction, right, as you can see the arrow. So that would be m2 v2I. So that's the equation set up for before collision. Now let's look at after collision. Now I have mass 1 which is moving in negative x direction, as you can see here. So that would result with negative m1 v1 final plus object 2 is moving in positive x direction now, and that results with m2 v2f. So you can combine both of these equations now. m1 v1I minus m2 v2I equals, right, net momentum before collision equals net momentum after collision. So that would be negative m1 v1 final plus m2 v2 final, and that is how we set up so that momentum is conserved in collisions. All right guys, so that's it for this lecture, and just make sure to like this video. I'll see you guys in my next lecture. Bye bye.